with 2030 agenda of the Sustainable Development Goals. To be more specific, it is closely related to the goal 11, which essentially is making cities and human settlements safe, inclusive, resilient, and sustainable. And in order to achieve this, one of the major requirements is that slums must be mapped accurately. So over the years, we have seen that the presence of slums have been escalating, and which is very much evident in the poorest nations. And as per the SDG report, it has affected 1 billion people globally. Speaking of the current stats, out of the 4 billion urban dwellers worldwide, 1.6 urban dwellers live in the slum regions. And it is also projected to increase by the mid of the 21st century. So the 2030 agenda, one major goal is the population well-being. So since the population well-being is one of the major goals, there is a need to map, there is a need for the precise data. So which is actually very much required and important for the urban planning and the development. There are existing data, but it is often imprecise or obsolete. So there are certain challenges that leads to the slum growth, which is rapid urbanization, migration to cities in search of work, poor urban planning, lack of affordable housing, and ineffective policies. So here, there have been traditionally, the slums have been mapped using the census data, but these we cannot rely on these data because there are often long temporal gaps between these data. So here is where remote sensing comes into picture, as it provides good spatial and spectral analysis. So in this work, we will be using Google Earth Engine as to map the slums. So it has been used, the Google Earth Engine has never been explored in the context of Indian slums. So we use this Google Earth Engine platform, which is essentially the cloud-based geospatial processing platform to map the slums. So our study area is Maharashtra. We chose Maharashtra because it is the India's second most populous state, and it had a population of roughly 114 million in 2021. And in Maharashtra, it has a high prevalence of slum dwellers. Basically, the slum dwellers are the rural migrants over there who come in search of work. And this is chosen due to the diverse and significant slum areas over here. So in Maharashtra, we have specifically chosen 5 cities, which are Kolhapur, Navi Mumbai, Panvel, Pimpri Chanchwar, and Thane. So there is a NGO named Shelter Associates. This Shelter Associates demarcates the slum boundaries of these regions. So we have used their data to validate our results. So the data set employed in this study is the Sentinel-2 multispectral instrument level 2A data. So we have basically considered those images which has a cloud cover of less than 10%. We have masked out the clouds and taken a median composite to the images ranging from the January 1st to 31st December 2018. So the features that we have employed in our study are the spectral bands of the Sentinel-2 dataset. And among the spectral bands, we have chosen 10 bands and left out the 2 bands, which has a resolution of 60 meters. In addition to spectral bands, we also use spectral indices, which are the different spectral indices that we used in our study are NDVI and SAVI, which essentially are the vegetation indices. Then is the modified normalized difference water index, which basically maps the water bodies, and the rest of the spectral indices, which are normalized difference building index, urban index, new built up index, band ratio for built up areas, and bare soil index. These are basically we can use this to map the built-up areas. In addition to the spectral bands and spectral indices, we also use the different texture metrics, and these are the different texture metrics that we have used in our study. These texture metrics are actually generated using the GLCM texture inbuilt in the Earth Engine, which is, we actually use the EE.glcm texture and compute these texture metrics. So this is the overall method overflow that we have used. So this essentially consists of the image collection and pre-processing. the collection of various features, the 10 spectral bands, the 8 spectral indices, and the 18 GLCM texture metrics, which gives us a combination of 36 features. So these features are combined, and and then we train 3 different machine classifiers on these features. The 3 different machine classifiers that we use are the SVM, support vector machines, CART, that is classification and regression trees, and RF, that is the random forest. And finally, we do the accuracy assessment of these. So as I already told that when we combine the features, there are a total of 36 features. We employ 3 different machine learning classifiers. And all these classification has been done on the Earth Engine platform itself. And we utilize the EE.classifier package for doing the classification. And to distribute the data set, we have considered the 70 to 30 ratio, wherein the 70% is our training samples and the 30% is our testing samples. So for the SVM approach, we have used the kernel function as the radial basis function. And for the CART and random forest methodologies, we basically hypertuned our parameters. The parameter that we hypertune for CART is the maximum nodes. And for the random forest, we hypertune the number of trees and the bagging fraction. So these are the classification results that we have obtained. The metric that we have employed in our study is the overall accuracy and the kappa coefficient. We can see that the for SVM, the overall accuracy lies between the range of 84% to 96%. For CART, it ranges from 84% to 94%, and for the random forest, it ranges from 86 to 97%. So to be more precise, we have also did a comparative analysis of the producer and consumer accuracy, and these are the results for that. In addition to the quantitative results, these are the classification maps that has been generated for the 5 study regions. So this is the classification map for Kolhapur, wherein the red dots indicates the predicted slum areas. The yellow part is the non-slum regions, and the black overlaid parts are the ground truth data that has been obtained from the shelter associates. So this is the result for the Navi Mumbai. This is for Panvel, Pimpri Chanchwa region, and this is for Thane region. So looking at the quantitative and the qualitative results, we see that the CART model specifically, the CART model is prone to overestimation and underestimation. And this is the reason, this is because of the complex slum morphology in some of the Maharashtra cities. And now remote sensing has its own limitations. That is it cannot capture the cultural and socio-political and economic dynamics of the slums. Also, the one of the reasons of why we are getting such accuracies and differences in the quantitative and the qualitative results is because the physical structures of the slums are influenced. Like there are different physical structures of the slums around different cities. So this study can also be enhanced wherein we can combine the remote sensing data with the socioeconomic survey data. And since we have utilized the Sentinel-2 data over here, we can also have a scope of utilizing the planet scope imagery, which has a better resolution compared to the Sentinel-2 study. So overall, we see that this study uses the Google Earth Engine's platform ability to assess the complex slum morphology in the Indian city of Maharashtra. Thank you. Actually, what we did, we were, as I said, that we considered this 36 feature input, right? So initially, we have considered more than that, and then finally, when we did this feature evaluation thing, feature importance thing, then we were finally decided to study. Since Earth Engine is a cloud-based platform, you're like running on one region and generating the output. It roughly took around 10 to 15 minutes. Like the final map was generated by them for all the 3 different classifiers. So all the processing is happening on the Earth engine itself. Yeah. Sir, what we did, like when we were considering these parameters and when we took in the training samples into picture, we have actually mapped these training samples according to the different features that we have considered so that we get a better accuracy for that part and the classification of the generated code. For the final thing, we have also discussed that is slums and non-slums. But when I was showing the spectral indices, and so and there we have 8 different spectral indices. For that, there were a vegetation index, water index, and the range for the and for the built-up index. So we took into picture that also, and then finally we concluded this slums and all. Study like there is the of the spectral band on that. I don't know that's the number. But the scale and accuracy. Roughly around 5 to 7%. We actually took that, we actually considered the feature important thing and then finally we landed up into. So like, if we speak of the most important features, so there were like among the spectral bands, the visible bands and the NIR band show the most relevant. The indices also shows, like that's why we included it. Sorry, sir? The bands were comparatively showed a more performance compared to the indices. But yeah, including the indices, the overall accuracy was.
Okay, every good evening to one and all. So I'm Sai Ganesh Veeravalli, a project scientist at National Center for Coastal Research, Ministry of Earth Sciences, Government of India. So today I'll be presenting on the topic UAV-based topographic survey of inaccessible remote terrains. So here is the outline of the study. So first I'll begin by framing our study within the broader context of challenges faced in surveying remote terrains, and then emphasizing on the significance of UAVs in modern topographic surveying. Next, I'll outline the UV specifications that made our survey possible and the methodological approach that we used to navigate the complex terrain of remote terrains. Then I'll move on to discuss the key findings and reflections from our data collection and analysis, revealing insights that are both scientifically intriguing and practically applicable. Then I'll discuss how these findings and the data helped us to develop some potential development strategies which are also sustainable. I'll end my concluding remarks where I'll encapsulate the findings, reflections, and the greater narrative of our study, highlighting the implications and contributions of our work to scientific community. So let's begin with understanding some of the challenges in surveying remote terrains. So I'll discuss a few of them here. The first one would be accessibility issues, and the lack of roads and infrastructure will make every journey and expedition challenging us to find new ways of reaching our study areas. Next one is the logistical hurdles. So reaching these isolated places and to deploy our equipment and personnel will require innovative methods to navigate through these terrains. And next important thing is ecological sensitivity nature of these remote places. So every environment demands our respect, and we should ensure that our footprint is minimal while we are exploring these places. And one more important aspect is weather conditions. often unpredictable and harsh weather patterns can disrupt even the meticulously planned surveys. So this will add a layer of complexity to the surveys. Next is equipment deployment. So each location has to have a tailored approach to reach that places and deploy our equipment. And the last one would be the communication difficulties. So the remote nature of these places often leaves us off the grid. So we need to make sure we find ways of staying in connected with the grid. So now we'll introduce our study area, which is Bellium Kallu Island, also called as White Island or Sacrifice Rock, which is approximately 36 kilometers from Kozhikode or Calicut in Kerala. Here you can see the white dot. This is the island actually. This is a zoomed in version of that particular place. So the photographs here show the island's untouched nature and the diverse topography. These rock formations are sculpted over the years because of the surrounding waters, and it tells a story of ecological complexity and geographical significance. And the island is untouched and remote. It's a natural fortress, kind of preserving raw essence of wilderness, and it is away from the touch of modern development. And the next one is its unique topography of this particular island, which is rising above the mean high water mark, is often prone to splash and overwash from the surrounding waters. And we can clearly see how these elements shape the rocks here. And coming to the geographical significance, it is steeped in history. Here, once Marakkar warriors fought against the invading Portuguese during the pre-independent era. So these tales of bravery and conflict got it the name of Sacrifice Rock. And today, it is very clear how important of a strategic maritime position it is in, with the ports and harbors just a few kilometers away. So the next is the ecological sensitive nature of this island, which has coral reefs and diverse species around it, which makes us ensure that while we are exploring its untapped potential, we make sure it is not disturbed too much. So I'll move on to the objectives of this study. There are two. The first one is to embark on the first in-depth topographical survey of this White Island, charting its contours using UAV technology. It is not just an attempt merely to map the island, but also to understand the nature of such remote terrains. The second one is to use this rich data to inform potential development strategies which are sustainable as well. The insights from this study need not be of site specific to this area. It can be a replicable model. It can be used as a baseline to understand such similar remote terrains across the India's vast coastline. So here is the UAV specifications. We used a SnapM rotorcraft UAV, which is from the company 3D Space Robotics, a Bangalore company. So it is a DGCA type certified UAV. It is not only known for its robustness, but also for its precision in geographical surveying, thanks to its PPK module. So this technology was crucial, especially in remote terrains, where collecting the traditional ground control points of the GCPs is not feasible. So the PPK system allows us to bypass the need of GCPs collection, streamlining the survey process without sacrificing accuracy. So it has a 24 megapixel camera with which we captured high resolution images for further processing. So let's move on to the data collection, which is a very interesting process. So our voyage to the White Island started with a boat journey in a fishing vessel from Koilandi Harbor, which is 20 kilometers away and approximately 70 to 80 minutes of journey. So when we neared the island, the fishing vessel could not reach the island because of the narrow, shallow, rocky fringes. So we need to transfer into a small dinghy boat, including our equipment and personnel in multiple trips. So once we reached the island, once we are on the island, we set up our drone base, which you can see here in the picture. And then we carried out our drone flights. So we did two drone flights, one at 80-meter elevation, one at 50-meter elevation. The 80-meter elevation is to cover the expansive coverage of the island, and the 50-meter elevation is to get the granular details of the island. So this dual attitude approach was crucial for us to get a comprehensive portrayal of the island, with the broader 80-meter one getting the strokes of the broader geography, and the 50-meter one getting the intricate details of the surface of the island. So this was conducted on 29th January, early this year, during the midday. Luckily it was a day with clear skies and midday sunlight with minimal shadows. And also it was done during a low tide time. And parallelly, another team did a bathymetry survey around the island to know the depths of the water. So coming to data processing, we use Pix40 software plus for processing the data. After a rigorous pre-processing and filtering, out of the 595 images collected, 264 were selected for final processing. So we created orthomosaic DSM, which we used for further. So we achieved an impressive resolution of 1.66 centimeter per pixel, which was very crucial in understanding its topography. So here is a 3D reconstruction of the island. If you see, you can focus on the central part, which is a massive elongated rock with multiple rock formations around the island, especially in the north and western direction. And you can see the topography, varying topography and the shapes of the rocks. So this was brought into life using the point load data, which was generated from the high resolution drone data, which we collected. So discussing the topography here you can see the central piece is A, labeled as A. So it has an area of 1 hectare of the total area, including small rocks. The elevation varied up to 12 meters with respect to the surface, which is touching the water during the low tide time. So up to 12 meters. And the depth varied around the island between 5 to 15 meters. So one of the favorable sites for any potential development was this site, which has uniform depth and it has access to the island, unlike this site where there is obstruction to the island. So because of its complex topography and varying heights and many obstructions, it has very limited potential for large-scale developments, but it offers very unique opportunities for specific developments that are very tailored to its location. So I'll develop 3 of those things. It can be a potential location for emergency hopping island due to its proximity to the fishing routes. And also you can see this is a natural rock formation which can act as a sheltered spot during times of emergency due to weather conditions or any other maritime emergencies. So next one is, this was done initially to explore the potential of tourism. So the east side where there is uniform depth and no obstruction, it can act as a place for tourism, especially for water sport activities. And the western side, the rocks can add an adventure for enthusiasts. And the last potential development is being near the maritime, very frequent maritime node. They can set up a maritime relay tower at the highest point of the island, which is at 12 meters. So it can it will improve the communications for the local navigation. So these are some of the potential developments which are low impact and also sustainable. So in conclusion, our journey with White Island was a testament to the UAV capabilities navigating through the complex terrains of which are remote. The detailed topographic survey which we achieved was not only provided valuable information, but also enriched understanding of such structures around the Indian coastline. The maps and data sets which were not present previously can now act as a foundation for further scientific journey. Also, this study serves as a blueprint if they want to see it lays a groundwork and it can be a replicable model for other areas where they want to do such similar studies. So this is the team which ensured our safety. Local fishermen, people who ensured our safety and have very good knowledge there. And this is the bigger fishing vessel and the smaller dinghy boat which we need to transfer in this sample of the drone image. So that's it. Thank you from my side. I'm open to questions. Yeah.
What was the then posting?
Sorry?
Then generation posting to them.
Posting in the sense?
Like the grid size of what?
That resolution was 1.66 centimeter per pixel. Yeah. No, it's not validated. We don't have any data in this area. It's a very remote location. No, there are no signals. There was no chance of collecting total station or nothing. So that's why we use this UAV specifically. And it's a PPK drone. So accuracy will be the horizontal accuracy will not be there now. Perfectly, it will not align. A vertical, there will be less than 20 centimeter accuracy. I'm not sure. I might not. Hello? Hello?
Hello, sir.
Okay. You can ask the question.
There are some hollow parts in the like rock formation which are hollow. So how you did with this kind of photogrammetry with UAV, because that part are not accessible with UAV, na?
The lower 50 meter elevation flight collected the information necessary to construct that hollow structures. So that is the reason we did a flight at a lower altitude. It is not 100% perfect. The hollow is not completely full, but it gives us an idea of what is the nature of the structure at those rocks. I hope I answered the question.
Yeah, yeah. Thank you. Very fascinating work.
Well, yeah, SFM only 80, 70. Yeah. One second, I have the values. Yeah. Side is 80, front is 70. Yeah, wind speed was not, it has a resistance of up to 10 meter per second. So it is not more than that. It can go till, even if it's 13, 14. Some images might be undulated. I mean, the angle might be different, but it was not that.
So good evening, everyone. Chairs Dr. Uttam Kumar and Dr. Armando. I am Shivam Trivedi, working as scientist in Regional Remote Sensing Center, South, NRSC, ISRO. And this study we have done in collaboration with MAHE, Manipal Academy of Higher Education. And this study has been done on application of high resolution satellite images for comprehensive spatial development planning at grassroots level. So as you're all aware, effective utilization and management of natural resources, this is very essential for national development, and it requires the spatial planning at grassroots level. And in India, for the rural India, we have a system of local self-government of villages that is called Panchayati Raj. It is functioning under Ministry of Panchayati Raj, MOPR, and Gram Panchayat is its basic unit. So sometimes there is one village in a Gram Panchayat, sometimes there are more than one villages in a Gram Panchayat. So this study was taken up for Ministry of Panchayati Raj, Gram Panchayat Spatial Development Planning. This is a pilot project which is completed for 34 Gram Panchayats in 13 states of the country, which is identified nationwide. And you are all aware about vision of ISRO: harness, sustain, and augment space technology, mainly for national development, while pursuing space science research and planetary exploration. So you would have all heard about Dr. Vikram Sarabhai, who was the father of Indian space program. So he said that we must be second to none in the application of advanced technologies to the real problems of man and society. So this study is a classic example where, you know, the science and society, they meet through space, they meet through action, linking of those things. So the study was taken up with a research objective of generation of natural resources information in the form of thematic layers like infrastructure, land use, land cover, slope, drainage network, water bodies, and a lot of other inputs using very high resolution satellite images, 60 centimeters and 70 centimeters data, generation of resource development plans for maximum utilization of land and water resources. So the study areas, there were 2 ecologically sensitive Gram Panchayats in the Kundapura block of Udupi district in Karnataka, India. So in the Upunda Gram Panchayat, there was one village, which is a coastal village adjacent to the Arabian Sea, as you can see in the location map. Shankar Narayana Gram Panchayat had Shankar Narayan and Kulanje, 2 villages. These were the forest-dominated Gram Panchayat located in the foothills of Western Ghats, which is a ecologically sensitive biodiversity hotspot. So a lot of inputs from Gram Panchayat spatial development planning were taken in the very high resolution satellite images, using which we derived the land use land cover map, the drainage and surface water bodies, geomorphology, and slope and contour using the DEM, the soil texture, agriculture map, and groundwater potential, and a lot of other inputs which are detailed in this list. The sources and the scale of which the map has been prepared is mentioned. So for the land use land cover map, basically we have used Cartosat 2 series of maps, and for some certain areas, ComSat 3 or 3A data also, which is Korean multipurpose satellite. And these are the other inputs that we have used. So the overall methodology, you can see all that yellow boxes are the input layers. So a lot of input layers has gone. So it is basically a data-driven approach. So Gram Panchayat boundary, using this, we have extracted NRSC spatial data. We have a project called SysDip Phase 1 and Phase 2 project. It is space-based inputs for decentralized planning. So the Phase 1 was done in the last decade, and now we have revised or updated that maps using the 2015-16 data sets. And we have also used the reference legacy layers. All these layers were updated with the land use land cover map, which we have prepared at 4,000 scale. So the high resolution data or DEM, that also we have used, and we have finalized on these inputs by integrating them in a thematic integration of thematic layers in a GIS domain. We have also done a detailed household survey for socio-economic and ground data for amenity planning, and using which the socio-economic map was generated. And we have basically prepared, using the remote sensing inputs, the land resources development plan and the water resources development plan. This socio-economic plan and the land resources development plan and the water resources development plan, these two became the main inputs for preparation of the master plan or the Gram Panchayat spatial development plan, which has been submitted to the Ministry of IIIT Raj for actual implementation at Gram Panchayat level. So this is the land use land cover map of Opunda Gram Panchayat. So as we can see that majority of the land use belongs to the cropland and to the agriculture plantation. So we have given a lot of suggestions on how we can improve the land resources and the water resources. This land use land cover map becomes the primary source of input for generation of other thematic layers also. So this is the road, which is a National Highway 44, Goa-Mangalore Highway. So this need-based development for this national highway is also proposed. So in this presentation, I will be mainly showing about one Gram Panchayat, and similarly, we have done for the other Gram Panchayat also. So this is the household survey information for Opunda, which we have done basically for amenity planning and to understand the socio-economic status of the people staying there. So the distribution of households was based on the house type, kacha or pakka house, the land holdings, the living conditions, water availability, toilet availability, whether it is a public toilet or a private toilet, the solid waste disposal, etc. So these are the research outputs. Basically, the land resources development plan and the water resources development plan. As from the field photographs, you can understand that this is a coastal village where majority of it is farming and it is a paddy dominated area. There are some dug wells and there are some streams and some pakka and some kacha houses. So the socio-economic status of these people are relatively moderate, not very poor, but there are people who are migrating out of their native location. So we have suggested as part of land resource development plan to adopt better management practices for certain areas. Supposing it is a single crop area, so if it is a level plain and the irrigation facilities are better, the soil texture is good, we suggest for going for a double cropping. So it will help in food security. Similarly, social forestry or plantation development, water bodies preservation, all these as plan of land resource development plan. And as water resource development plan, we have suggested locations for rainwater harvesting and dug wells, where the farm ponds can be located, where the water conservation practices need to be taken up, percolation pits can be set up, and preservation of aquaculture development. So there is a lot of fishing community also staying in this coastal village. So this is the other Gram Panchayat, which I was mentioning. So as you can see, that majority of this area belongs to forest as well as agriculture plantation. So here we have to focus on sustaining the native vegetation in such a way that it is a sustainable development as well as there is some livelihood improvement for the residents also. So conclusion is the utilization of space technology, as I mentioned earlier. So it is basically for the benefit of common man reaching the last mile, or what we say is last mile connectivity. So it's a data-driven approach for sustainable community development with the emphasis on local planning and resource utilization. Here we have done the application of very high resolution images using this ancillary data household survey. We have done this for the ecologically sensitive Karnataka Gram Panchayats. And we have also taken this up for 4 other Gram Panchayats of Tamil Nadu in our office. And reliable scientific inputs, which were they help for the development practitioners, government officials, and local level planners to adopt the Gram Panchayat for better land and water resource management for actual implementation in Gram Panchayat level. So all these inputs for all the 34 GPs are available in our Bhuvan Panchayat web portal, Bhuvan Panchayat 3. So you can actually, prepare, overlay the layers as and when required in a way, and you can actually download the profile report from there. You can plan an activity there. So these are the details. This is what I'm showing for Upunda Gram Panchayat, the dashboard view for Upunda, and the dashboard view for the Shankar Narayana Gram Panchayat. So based on all this, we have given certain recommendations, a summary of which is Upunda village, develop it as a sustainable coastal village, assuring livelihood of villagers and fishermen community, socio-economic development by capacity building, while preserving and managing natural resources responsibly by regarding the coastal ecosystem. This is one example. The other example is for our natural assets, where we have in Shankar Narayana, sustainable villages that embrace its natural assets, encourage the community development, empower the people, provide opportunities to improve their livelihood. And as I said earlier, in this ISRO Geo portal, Bhuvan Work portal, now following the success of this pilot study, in each state, one district has been picked up, and the land resources and water resources development plan are there being generated in an automated manner using this LRDP and WRDP tools. So this is already in progress. And the Sustainable Development Goals of United Nations, this is this kind of a study. When we take into consideration all the 34 GPs that have been done, they are contributing to 7 out of 17 Sustainable Development Goals, like zero hunger, which is contributing for the food security. And then we have increasing per acre yield, clean water and sanitation by suggesting locations of farm ponds and percolation tanks, decent work and economic growth by providing employment opportunities at Gram Panchayat level, industry, like setting up of agriculture processing industry, rice mills, coir industries, fishing industries. And then we have sustainable and sustainable communities, the sustainable rural community for overall development of the area. And we have climate action. So climate action at micro level, and life on land to improve the overall quality of life for the residents of these Gram Panchayat, hence contributing to overall national development. Thank you so much. Thank you, sir. Yeah. The land use land cover map, since it was a very high resolution data, 60 centimeters data, it has been done manually. It has been done using visual interpretation. Yes. Yes. Yeah, and there was a lot of ground information and household survey data also was available for that, which we have made use of. Because at that scale, you are able to see individual farm ponds also. So this is a very detailed data where you are able to see single trees also. Yes. Over 200 points were taken for each Gram Panchayat. No, for the Gram Panchayat. So the area of this Gram Panchayat is only about 583 hectares. It's not a very large. Upunda is only one village. Yes. So this household survey was done by our collaborating institute, MAHE, and the remote sensing component was done by ISRO. Yes, sir. Yeah, sir, actually the Ministry of Panchayati Raj, who is responsible for overall development of all the rural development, they are the main users. They are users of our, yeah. And anybody, even right now, we can go and do that amenity planning because everything is available. You just add on the layers and you download your profile report and you can actually go for the planning. Yes, yes. Yes. No, it is a unique thing that has been done first time. And initially it was done, as I told her, it was the map was prepared manually. Now, as part of a larger national project called SysDip, we have land use land cover map for the entire country updated at 1:10,000 scale. So that using that as input and using a lot of other ancillary inputs, which goes into this planning. Now it has been done now it is being done for one district each in each state of India in an automated manner. There are some LRDP and WRDP tools wherein you feed the layers and you get the map out. Yes. Yes, sir. We need to buy the data. Yeah, we have purchased this data through NDC. So at that point of time, 2018-19 data had come to NRSE, for geo-referencing and ortho-rectification. As part of that, we had got that data. Yes. Yeah. Yeah. Yes, sir. Sir, actually, this particular part was done by the partner institution. They are more into socio-economic data planning. So this was done, but it is basically, bringing all the data together in a common projection and making a union of those layers and on overlay method. This is what has been done. Yes. Thank you so much.
Hello, good afternoon. My name is Ellen. I'm an independent researcher and a consultant. This is actually a talk a little bit out of the domain what I've been doing for the past few years. This is more on agriculture. This is not on agriculture. This is the opposite. This is on urban. And this is something very local. This is an analysis in Google Earth Engine. The question is, looking at urban heat islands in Bangalore at the ward level. So a brief overview of the agenda. So an introduction, why would we care in Bangalore to even look at that? What is so specific on Bangalore? What is the study area? Then the approach, and then the conclusion and the next steps. Maybe I think some of you are from outside. You must have seen all the traffic in Bangalore. There are many studies already done, I think also by Dr. Rukam as well, on the increased urbanization in Bangalore. So I'm not going to talk about that. What is specifically an urban heat island? So this is basically that the urban areas are warmer than the non-urban areas. And so the contribution of this paper is threefold. So we're looking at the decentralized level. Why is that Bangalore is so unique? If for those of you who are not from Bangalore, we have something called wards. We have some 243 wards. This is about 40 to 50,000 people, and there's a ward committee. And what is unique about it, that each and every resident can actually go to the ward, and there's a corporator and all that. So this was actually to see whether at the ward level are certain areas warmer than other areas. So so this part of the study is I followed, as you will see in the next slide. This is done in urban in Google Earth Engine, and for some of the studies they use existing LU land cover and land use maps. So what I've done is to actually combine it with I've created it myself. So in Earth Engine, you can do this fairly easy, except for the sample taking, as we all know that is the most painful process. And the third thing, like I said, it's done in Google Earth Engine, and you can always contact me. I'm happy to share the code, what I have done. So this is the study area. This is Bangalore. So I go fairly quickly over to that. So we have the water bodies have decreased. Also, the vegetation cover has decreased. As I said, many other studies have been looking at this already in Bangalore. So, so the approach consists actually of 5 steps, and you can do this for your area. You can do this even on other areas. Anything that this is called zonal statistics. So basically, the zone is a ward. So where you come with summary measures. So first, the first step was to take the shape file of Bangalore with all the wards, and for Google Earth Engine, it was a GeoJSON. Had to convert it first. You can do this in any software. This was done in GDAL, and then it is a computation of the land surface temperature. And in Google Earth, you can actually do the long method with the emissivity, the fractional, the vegetation cover, NDVI, etc., etc. And a good book, if you want to understand it, is chapter 815 of cloud-based remote sensing with Google Earth Engine. They give all the steps, but it is also plugin. You can do it very fast. This is just also in Earth Engine of Ermida et al. So this is what I have used. As I said, so then I used a land classification analysis where I took a random forest. You can do an SVM and all that, which we have seen in other presentations, but I chose to do a random forest, and it's with 55 trees. So I did some experiments on the hyperparameter tuning. Then what I did for urban heat island, so as I said, the temperature in the surroundings is lower than the temperature in the urban pixels. So there are many ways of doing it. So one way is saying, okay, I'm taking a buffer around my administrative boundaries of Bangalore. Is it 10 kilometers, 20 kilometers? Some say it depends also on the extent of the city. So there is something called a simplified urban heat island. This is also in the book. So what it basically does, it takes the boundaries itself. So you look at the urban pixels, which you get from the land use and the land classification itself. And then for each and every pixel, you're going to subtract for within the Bangalore boundaries, what is not urban. But water is masked out, as you will see. And the last step is the zonal statistics. So this is the LST result. And the water pixels were masked because water can distort it. And the way this was done is the global surface water data set. Again, you can read this in Google Earth Engine. So then that was the more painful exercise, is taking all the samples for the land use, land classification. This was again, so we had urban, water, vegetation, and other. Yeah, this is just the amount of samples. Okay, I took a little bit more on urban, but there's no specific reason for that. So the training accuracy and the kappa statistics was about 0.99, and the validation accuracy is 0.85, and the kappa statistics is 0.80. And if we look at the LSP per land classes, so this is the map. It is in urban, it is as expected higher in terms of the temperature. So the next thing was, as I said, this is not having a buffer around the city of Bangalore. This is a simplified measure. And so you take the urban pixels. So this was urban as from the land use land classification, and then the non-urban, which was the vegetation and the other, basically. Then, so the metric was then computed, this simplified urban heat island. So for all the red pixels, you subtract the mean of the non-urban pixels together, and this is what you get. So the next step is then actually perform the zonal statistics per ward. So this, again, you can do this easily in Google Earth Engine and then rank it. So where are the regions which are having high effects and where are the regions which are the low effects? So this is, so the green is with the low urban heat island effect, and the red is with the high urban effect. So then this is also what came out of the code. So in terms of ranking, so the Banashankari, Madiwala, these are regions that are high in this urban heat island, and this is for the, these are the lower regions. So wards located in the north to southeast have lesser simplified urban heat island effects compared to wards located in the southeast. So the next step could be, okay, what is determining it? That is it because of water and all that? Also, if you look at seasonal effects, would the ranking still be the same? Also, this was using now in Landsat collection 2, level 2, there is a specific band where you can directly compute. You don't have to do all the steps anymore. So is the ranking still the same? So that it's kind of all a robustness analysis. Look at day and night. That won't be possible with this Landsat. You have to go to other satellites, like the mode is one, the Aqua, the Terra. They do that. This has a lower resolution. Also look at temporal analysis. Has the ranking changed? And as I said, please feel free to contact me. You can always try this also on other cities, use other land use classification, do other experiments. So this is my email. Thank you. Yeah, sorry, I forgot to mention. No, this was actually the Landsat. This was for 2022. This was a median composite. So there's a whole step before that. Like first you have to, so I took the entire images for the period. Then I think I had a cloud cover that I said, like the bad clouds, take it out. And then there's a cloud score in Landsat. So there's masking, and then do the median. Yes, it's a median. Yes, I forgot to mention that, but it's a median for 2022, median composite with a cloud masking, which is in the Landsat available. Yes, that's actually one of the things that I said we can extend, like look at the seasonal effects. I specifically said, okay, let's look first at the wards, and then is it in the season, because it can be very different. Yes, at nighttime also, but we cannot do it with the Landsat sensor anymore. We'll have to go to the sensor that has the morning and the evening, which is like the Terra and the Aqua sensors for MODIS, but the resolution won't be that good as this, but this is possible to do that as well. Sure, sure. Yes, actually, I'd be happy to share the code. You actually have to just put in a shapefile that has the walls or even a bigger area. Let's say you can any area that has like zonal statistics you can do, or even, yes, that's the beauty about using Earth Engine. Like once you change a shapefile, you can use the rest of the code. But it's very much, I'm happy to share the code with you. Simplified, because it's not the buffer around it. It's only in the, you know, use only the pixels inside, because especially Bangalore, I think you must, I mean, you've written, I think, some papers. The urbanization has just gone out of this thing. So I thought, okay, let me take that specific metric, the simplified one, because we won't have the discussion of what is outside, what is inside. Let's keep everything inside. That's the reason. Yeah, that is something that like calibrated in the sense I've just used the code. It's not like ground truth I have, you know, compared it. Yeah, I've not seen it also being done in other studies on LSTs. Like they're just like, okay, they say this is the method and we're following that. But yes, that's because even if you take Landsat 2, collection 2, you see a difference. Because initially I started with that and I found the numbers were higher. And from, yeah, that's something, I mean, at least I'd like to look into. So, sorry. Actually, when you use the plugin, it's all incorporated. So you can use either a plugin or you can use all the steps with emissivity, the fractional vegetation cover, etc. Yeah, but that's included. Yeah. I'd be happy to share that with you. I live in Bangalore. No, I have not done it in this specific study, but that's like in one of the point, like what factors? Like, is it because in that specific region, there are more buildings? And I think Uttam sir also has a paper on that, right? That he looks at specifically the buildings and there is a correlation. So, yeah. Yeah. Thank you.
So, good evening, everyone. We have a lot of talks about Earth observation, remote sensing. So let me take you to millions of kilometers away to the red planet Mars. So my paper topic is the interannual variations in snow albedo in McMurdo Crater on Mars. I am Sehpal Singh, PhD student under Professor Deepika Singh at CSRE IIT Bombay. So this beautiful image is the image of Mars South Pole. As you can see, this is a beautiful layered structure of snow and ice. And here, this small dot is my study area, McMurdo Crater. So basically, why Mars? Basically, it is the most accessible planet and possesses resources and minerals similar to Earth. I suppose you must be thinking we have a lot of problems here on Earth. Why are we going to Mars, or why are we talking about that? Of course, we need to solve Earth-based problems, but parallelly, we also need planetary exploration. Why? Because one day or the other, Earth would be getting devoid of its resources. So Mars can be a savior against dwindled resources on Earth. We have a lot of similarities to Earth. If in the case of Mars, we have Martian ices at poles similar to Arctic and Antarctic here. We have atmospheric layers, we have water ice clouds, we have volcanoes, we have canyon system, and we have a lot of valley networks. Of course, they are now all dried up. So learning about the Mars climate can tell us about the evolution of climate of planets. So basically, we can understand the fundamental processes that alter the planets, like the changing physical features of any planet, the climate system. So basically, this is called comparative planetology, where we study the similarities and differences between two planets. And this can be interesting as studying Martian climate and its geology can provide clues to the potential life-bearing signatures. So this can possibly answer the past or present origin of life on Mars or any other planet we are targeting. So apart from the exploration of the planet itself, these kind of planetary explorations also bring us the advancement in new technologies that could benefit the humanity. So here is the Martian elliptical orbit, as you can see. So just like Earth, Mars has seasons. We have winters, summers, autumn, and spring. So this is basically 0° LS called solar longitude. So 0 to 90, this is spring in the northern hemisphere. This is the summertime in the northern hemisphere, and this is autumn, and this is winter. And this will be vice versa for the South Pole. So my target of observation is basically this 270° to 360° LS, which is the summer season in the South Pole. Why we are dealing with the summer season, you will come to know. So basically, the cryosphere system of a planet is the most sensitive and informative indicator of a planet's climate change. Also, the albedo changes affect the planet's, it triggers the climate activity, and we can know about the energy balance of the planet. So the Martian South Polar Cap is composed of CO2 ice overlaying the water ice. We have a lot of global dust storms on Mars. Like here on Earth, we have regional or local storms. On Mars, these are the sporadic phenomena as they occur approximately every 3 to 5 Martian years. What happens is that there are a lot of local or regional dust storms. Basically, they evolve and they merge together to form a global dust storm that engulfs the whole planet. And we completely get the obstructed view of Mars. It becomes too hazy to identify any physical features even from a telescope. So basically, the albedo can change when the dust is deposited on any high reflecting physical feature like snow. So it can change its reflective characteristics and ultimately affect the temperature of that region. So affecting the temperature of the polar cap, this can alter its polar heat budget. So studying surface albedo changes can also provide insights into how these dust storms alter the south polar regions, energy balance or thermal properties as I mentioned. So my study has two aims: to study the interannual variations in the albedo of snow-covered regions of the south polar of Mars, and to understand the impact of the global dust storm, which occurred in the recent one occurred in Martian year 34, that is in 2018. So my study area is McMurdo crater, as I showed in the first initial slide. So this is basically my study area. So why I am targeting particularly this area? Basically due to before the observations of Martian year 34's global dust storm, some precursor dust storms were noted in the Hellas Basin region, which is this region. This is the deepest basin in the entire solar system. And some also regional dust storms were noticed in the near the polar edge of the South Pole. So basically it's 23 kilometer in dia, and it's basically lower in elevation, as you can see this from the digital elevation model. And this is basically thermal emission imaging system, a high resolution 100 meter per pixel, though it's not that high resolution. We also have 6 meter up to 6 meters of per pixel resolution of the Martian areas. So basically I have used hyperspectral imager, use the technique of imaging spectroscopy called the sensor is the CRISM Compact Reconnaissance Imaging Spectrometer. It is on board NASA's MRO, Mars Reconnaissance Orbiter, which is orbiting the red planet since 2006. It has two detectors, visible and near infrared, working in the 0.3 to 1 micrometers. It has 107 channels, and the L detector, near infrared region 1 to 3.9 or 4 micrometers. So the problem was that this hyperspectral sensor has a cryopolar system. So in 2018, that got failed, and we were only left with the observations in the visible near infrared. So I've used MSV multispectral, VNIR and HSV modes. So we processed and analyzed about 40 plus observations ranging for the 4 Martian years, Martian year 32, 33, 34 and 35. So basically this is the comparison of Earth and Mars calendar. So basically Mars year 32 started somewhere around 2013 and I have gathered data and processed it till 2018. So Martian year 1 began on April 11, 1955 according to Clancy et al. Paper. So this is my methodology. I have taken the CRISM ARDR dataset from Planetary PDS Geoscience node. That is not NASA's planetary data system. The data is publicly available, all the planetary data. So I converted it to the CAT CRISM analysis toolkit in NV. So there is a particular toolkit developed to process and analyze these kind of hyperspectral images. I did photometric correction and then obtained a projected single cube, hyperspectral cube consisting of 100 channels depending upon the observation mode of that sensor. And then using the GDAL, I generated a single broadband albedo raster. So this is nothing but weighted by the spectral irradiance flux of the sun. So, and the true color products and the RBR products, basically this red-blue ratio products are used to separate ice from the soil using only the VNIR wavelengths. So this is basically a beautiful image of the crater. This is of Martian year 32, 33, 34, and 35. Enough observations for the year Martian year 32 were not available, but we can see a beautiful mosaic of other Martian years. So Martian year 34, basically this is, we can see the ice content is less because these are relatively older strips near 300, after 300 LS. So this is, I have identified the snow cover and these are the albedo values for Martian year 32, 33, 34 and 35. We can see they are varying from 0.1 to 0.6. Here we can see the snow has a very high albedo near about 0.8, 0.9. But this is due to the amount of dust present in the Martian atmosphere and near the surface during the global dust storm. So this is basically the comparison. As I mentioned, enough detector observations were not available for. As the interesting thing is that there is little or no ice on the equator facing wall of the crater, because ultimately during the summer the equator facing wall is sunlit during the whole day. So coming up to the snow albedo changes, the variation in the maximum and minimum values can be attributed to the amount of impurities present in the snow. So we can see that at least the Mars dust can reduce the snow albedo by 75% or 0.49 by this values. As you can see, we have a maximum value of snow of 0.58 and minimum of 0.12, although these are the values of only the snow covered region. We can see that the maximum, mean and minimum values, all of three were the minimum for the lowest for the Martian year 34, because this was the year when the global dust storm came. You can easily point out in this graph, this dip during the Martian year 34 in the mean, maximum and minimum values. Most interesting thing was that the fall and rise of these values was equal by about 17.5%. During Martian year 33, it got dipped by 17.5% and again, regained that value. So this explains this has a significance in maintaining the icy surface energy balance, and it also suggests that the dust deposition was reversible and temporary and reversible. So it indicates a clear link between the atmospheric processes and the energy balance of the system. So coming up to the conclusions, dust storms can temporarily alter the reflectivity of reflective properties of the surface, which have a significant implications for the local climate and the polar heat budget in this case. The mean albedo values were found to be lowest for Martian year 34, and we hypothesized that the local alien processes and CO2 sublimation and deposition cycle, because there we have ice and the ice gets sublimated directly to gas and again it condenses during the winter. We have no liquid phase of water ice and CO2 ice. So this hypothesis can explain the recovery of the surface albedo to the for Martian year 34. So substantial variation in the maximum and minimum values of snow albedo signify the brightness contrast in the contaminated snow as indicated by some previous studies. So these are the references. Thank you for your attention. Any questions? Yeah. And so I mentioned that you can observe that these are the summer values. So the albedo can decrease at least by 0.49 or 75%. You see this minimum value 0.12 and this 0.58. This, yeah, every year there will be dust storms, but that are not global. They occur on some particular areas, and then they are faded by the time and the wind. Did you get that? I answered your question? Yes, please. Yeah, thank you for the question. Actually, yesterday only, 2 days before, our paper of mine has came. We have, the paper is about the ancient mega floods on Mars. So we have a lot of outflow channels. The main author is Professor Praveen Kumar Thakur. He is currently head at Water Resources Department at IIRS. I was basically MTech student under him. Now I'm doing PhD in IIT Bangalore. So there we have used the Mangalyaan data because, of course, it was the main purpose was of Mangalyaan was technological demonstration, but we did try to deduce science out of it, and we have published the paper. I'll share you if you are interested. Thank you. Thank you. Thank you. Good evening, all. Myself, Abhijit, first year PhD scholar from Indian Institute of Space Science and Technology, Toronto. So these are some of the findings that I would during my early PhD time. So mapping high resolution digital terrain model using terrestrial LiDAR scanner in a mangrove wetland ecosystem. So that is the title. So mangroves, as we know, it's tropical, subtropical faculty halophytes that will be colonizing most of the variety of coastal geomorphic settings. So as a geomorphologist, I am very new to geoinformatics. So here I am trying to incorporate like what are the options, like opportunities in the geoinformatics to study, to link between two disciplines. So here, whenever a geomorphologist hear about like remote sensing, the first thing comes to their mind is like digital terrain model or digital elevation model. So I want to study the microtopography of the mangrove wetland ecosystem. So first I tried to create digital elevation model from synthetic aperture radar doing SAR interferometry. Then I did like using drone data structure from motion that also we did. So what is the problem is like for studying microtopography, we should go into the scale of 1 to 100 centimeters. That is not possible using synthetic aperture radar or even with SFM models, especially when we go to mangrove. In open area, it is possible, but when we go to mangroves, it is very hard to get the oblique angle so that we can retrieve the ground points. So why microtopography is like in mangrove wetland ecosystem, it can directly influence the salinity, hydrology of that entire ecosystem, species distribution, and the tidal inundation pattern. So generally, when we talk about microtopography of a mangrove wetland ecosystem, we will be focusing on two things. That is, one is hummocks and hollows. Hummocks are the elevated mounds, which are usually like 25 centimeter, approximately extending above the water surface. So hollows are flat low-lying regions, but it is also above the water table, but only 1 to 3 centimeters. And why microtopography is like, if I am getting the very high resolution digital elevation model, so I can study all these biogeomorphology parameters comparing that. So earlier approach was like getting a high resolution digital terrain model, high grade, like high precision survey grade GPS were used, and like manual surveys transecting all these methods were used. Later, airborne laser scanners were used. But the problem there is like the point density is not insufficient to map the microtopography. That very small scale topographic features cannot be like extracted. So the next option is like close range remote sensing technique. So the best thing is like terrestrial laser scanners. So in our department, we have terrestrial laser scanner, and it is able to extract the high resolution dam even like less than 1 meter square spatial resolution, 1 by 1 meter. So here what I did is like, I want to get DTM out of the point cloud, which is like generated using this LiDAR points cloud LiDAR scanner. And I use two approach. One is Q-Canopy classification. Other one is mostly used like one of the tool that is cloth simulation filter, that is CSF method. And both were compared. This is a study area. It's in Jaidapur, like Maharashtra, and mostly predominantly it is Abyssinia genus, and the creek were inundated during the tide, so we prefer to collect the data when it is like low tide time, and we observed that from the field itself, we observed that the tree height were observed to decrease gradually toward the creek direction. So the elevation is having some role in species distribution and the elevation pattern of that particular tree itself. So this region will be getting precipitation mainly from southwest monsoon, and the methodology I use, like we collected the data on 13th of December 2022, and it was like low tide period, and a plot of 35 by 35 meters were selected, and we did the registration, LiDAR point cloud registration using the proprietary software Parosine. We were using Paro only, and the scans were having 31% overlap, and all the observable spheres were like identified, and we did that transformation, whatever we will be saying as point cloud registration. We did it, and we were getting a very high quality point cloud, which is having like 11 millimeter error. And then we use Cloud Compare. It is an open source software for the pre-processing and classification of the registered point cloud. And we have seen this. This is the study area. Since we are only interested in extracting the ground points, we just clip the data to 50 centimeters from the ground. So this is the entire methodology. So this is the framework for classification algorithm, and the second cloth simulation filter is just a tool. So first what we did is like we clipped that above 50 centimeter, and we calculated Z coordinate. That is nothing but elevation. And using the gradient thresholding, histogram thresholding, we were able to separate ground points and non-ground points. But the problem is there are a lot of noise points there. So we were using verticality, that is one of the geometric feature. Again, histogram thresholding on that, and here we are creating the label points. So SOR filter were applied like 1 sigma 6 points, and ground training class were achieved. Similarly, we only change is like we were using 2 times SOR filter here and 1 sigma 6 points, and we were getting the training points for non-ground training class, which it will be having both nematopods, that is nothing but the roots of mangrove, and the tree stocks. And we both are labeled point clouds. We merge it into a single point cloud, so that we will get like single point cloud with both classes. And then we did Kennebec training. It will be having both dimensionality and the scalar field. Scalar field is nothing but geometric descriptives, which is combination of different eigen values. And here we got the classified output. that is non-ground points and ground point. We are not interested in the non-ground points. So ground points are point clouds. It's point clouds. So point clouds are not digital elevation model. So we want to interpolate that points. So by interpolating, we got the digital terrain model, and we can extract the complete point cloud generated, which represent the digital elevation model, but we can export in like GeoT4, mesh, hillshade, whatever the format we want. And from here, it is raw point cloud. We directly calculated using, try to extract the digital terrain model using cloth simulation filter. So it will be having lot of noise points. I will show the results. Then through the same process of kriging interpolation, we will be getting the digital remote. This is the class separability of Q-canoport training, and we were getting about 94.22% of balance accuracy. So these are the parameters for the classifier for the dimensionality part. So we did like many hyperparameters used for this particular classifier were like tested, so that the optimal value is selected. And for cloth simulation filter, we used like 1000 iteration and 1.5 centimeter cloth resolution for getting that points, ground points, for filtering out the ground points. And the digital terrain model was extracted using the kriging method. So this is the result. So we can see in the blue, like that is ground, and in the red it is pneumatophore plus whatever the tree parts which are there. So this is the cloth simulation filter output. We can see here we can see the points. This is the point cloud that we have generated, and you can see the noise point, because our model was only having 94% accuracy. So this is not ground point, but after generating like that kriging method, we will be selecting like what are the points which is on the lowest part. So we will be getting the complete using interpolation technique. We will get the terrain, and this is the output of cloth simulation filter. Lot of noise points will be there. You can see the hummocks, and in between there are like low elevation region. This will be interconnected, and all these very micro topography will be controlling the water flow while the tide is getting inundated. And discussion is like what is the advantage of classification method when compared to cloth simulation filter is like, once we are creating the classifier in a .prm file, we can like just apply to other area. We can directly retrieve the ground points. But cloth simulation filter is like the entire point cloud was around like 16 million points, and you see the area, it is like less than 25 by 25 meter. So it is not possible to like digitize or just delete the erroneous point. And I am using like i7 i7 processor. It took me 2 days to get the result of this small area. So you can see like how much computationally expensive it is. So now what we are working on is like from the insight of this, classification approach is better than a tool, that is cloth simulation filter. Now from this insight, this is a binary classification. So for last 2 months, we were labeling another huge data set into different classes, class labeled. So we will be feeding this into some other like framework, maybe deep learning or other machine learning techniques, so that we can get some multi-class classifier, just like this binary classifier. Here the insight is classification approach was very efficient. Cloth simulation filter have that limitation whenever the point density is getting reduced. When we are applying this statistical outlier filter, even ground points are getting removed. So filter method is not efficient for generating high resolution term, but the classification method is, and we are trying to create like one new classification method. It's a team, like it's point cloud spacing. We will be saying point cloud spacing. We did like a medium density scan. It was around like 1.5 centimeter in some area.
MLS is LiDAR itself is expensive. Our university is having TLS. It's itself is like 50 lakhs. So we were making. Yes, if we have the data, if we have the instrument, we will be going for MLS. But TLS, that is true because if you want to get the ground points, natural occlusion will be there, vegetation will be there. When we go to the field, we will see that. Yes, that's true.
And for the chemical classification,
so
you are concluding that chemical is giving much better results.
Classification method, yes. But we are trying to create one other classification method. Yes.
What about the terrain?
From the result, it's there. You can see this is in Cartesian coordinate system. We didn't use any. Yes, sir. It's in Cartesian coordinate system. You can see whether I don't know. It's changing between almost 40 centimeter difference is there. 40 to 45 centimeter difference. In mangrove we cannot expect some high relief. That we didn't test. No? Actually, that is true. People have. I am working on mangrove. Mangrove ecology is my area, and the landscape of particular ecosystem is entirely different. Like you can go to Shivalik and say like that. We will take different approach. This is limited to mangrove ecology only. There we can use ALS because we are not going for micro topography, which is in the order of this very small centimeter. There we can use ALS, which will be having 50 points per meter square. Actually, that is a classification validation itself. Like this terrain itself, we didn't validate. Confusion matrix, that is class, interclass. Two classes. One area we took the label and we tested on unseen data on the same plot. No. Actually, 25 by 25 meter area was there. We were taking labeling data from one. For classification, we need labels. So two classes, ground is there, non-ground is there. So ground data, we will take the label. That was the entire workflow, what we did here. This entire process is to get the ground training class. This entire stretch is for non-ground training class. We will get both training class and we will merge into one single point cloud, which is having both class. So this is the input to Kenepo classification. So it is having label. We will be training on some data set and we will be testing, just like machine learning algorithm, what we do. In inundation pattern we can study, yes. Actually, like I want digital terrain model. First year I just started my research, so this is my requirement. So I am working on this. After that, we can like one application I will say, we can see mounds, no? Mounds and like hummocks and hollows. So mangrove, some plants will be like seen more. Plants are like selecting this mounds region to grow because other hypoxia condition will be there when it is getting inundated, and there will be like plants will be taking up all these nutrients and evapotranspiration will be happening, and the nutrient cycle will be getting affected because of the pore pressure difference. Water is getting evaporated, pore pressure that gradient is created. So a lot of opportunities are there once we are getting the digital elevation model, especially in the mangrove. For Indian mangrove, the studies are like still lagging.